As you might figure it out, my name is Balazs Kreith. I am a senior software engineer at Riverside, where I'm responsible for maintaining and developing the WebRTC infrastructure and powers the company remote recording and podcasting platform. My journey for WebRTC started 10 years ago, where as a PhD student, surprise, researching and developing congestion control algorithm for real-time media in a multipass environment. And I joined Karlstad, one of the first WebRTC company, and that's the reason why I moved to Finland. Later in 2021, I joined Whereby as a full-stack WebRTC developer, and this time not just evaluating the quality, but also actively maintaining and developing components for WebRTC calls. Since 2023, I joined Riverside, where I'm continuing this work at scale. Today, I'm going to talk about some tips and tricks I learned on the way, how to evaluate the WebRTC stats, how to make might be meaningful data, and how to use it for your own benefits. I hope you will find it useful. So let's dive in. Let's start with what WebRTC stats actually are. In the browser, RTC peer connection getStats method gives you metrics about RTP streams, RTC behaviors, codec performance, etc. These stats can form the basis of quality of service, and how you are evaluating it is depending on whose expectations you want to meet. Let's take a simple example. Alice is on the call with Bob, and all she sees is a black screen. Never happened with anyone. For Alice's perspective, it is unacceptable. All she cares about that it gets fixed. From a manager perspective, it should be known if it is a one-time glitch or a systematic failure. And from the developer point of view, the issue needs to be solved, so the root cause needs to be found. And here we have quality of service metrics, which might be helping in order to analyze and then satisfying some requirements, and three different expectations. Users cares about experience, managers cares about impact, and developers cares about finding the root cause. And by having quality of service metrics, one of the main goals is to approximate the quality of experience. The quality of experience reflects the user perception during a call. When we are turning out to have WebRTC stats in practice, we are polling it, and then we are calculating and transforming it into the insights. Let's say the basic insights we are transforming is bitrate, because you need to poll two consecutive stats. And from bitrate, you can identify if the media, for example, flows, first of all. But the interesting thing is that, here is the first key takeaway, is to use the application context. Because if you just have WebRTC stats without application context, and then let's take the previous example, where the black screens for Alice, you're seeing that the outbound streams are flowing, but the inbound streams never receives anything. And then you are saying, okay, so the issue is in between the two. But if you just attach an application context that the virtual background has been applied, you wouldn't go to the SFU code to figure out what could go wrong, because it's an outbound RTP streams transformation issue and not a networking issue, nor an SFU issue. And using application context goes beyond the single case. For example, you can detect CPU spikes as an application context or tasks which the users interact, and then you can correlate it with discarded buckets or dropped frames, so you can identify devices which cannot keep up with your application. So the key takeaway, and also it's like, interestingly, when you have it, you can immediately calculating the KPIs, how many calls were affected with your bug. You can immediately pinpoint the issues for the developers, and the users can get, better experience a bit sooner. So the key takeaway is that the challenge is to provide meaningful insights from WebRTC stats on the base of the quality of service metrics, but it often requires for the application context to correlate it with the stats. That's the first key takeaway. And scores, because this is one of my favorite questions. Whenever we are talking about evaluating WebRTC stats, talking about designing a component or any services, the question was that how was the quality in meeting X always comes up. It's one of the first questions I'm getting when we are talking about it. But for me as an engineer, when somebody is asking this question, it's like asking a blind person whether the sky was cloudy yesterday. Because it's a little bit hard to say because I didn't actually see it. In order to having meaningful scores, calculating, we need to consider 3 components for WebRTC or for any real-time communication system. One is the audio-video content which is produced and delivered. The second is the network reliability, and the third is the system context. The audio-video content are the tracks which is producing the video and the audio. The network reliability is ICE connections, renegotiations, ICE failures, and congestions. And the system and the environment stability or the system context is the application, the device, and all of the context which we can gather from the client. When we are talking about calculating the scores, we always start with the audio-video content. That's, of course, the central components of any kind of score calculation. But if you are investigating what kind of available score calculation is, that you will find traditional like MSSIM, SSIM, or PSNR. And those are not feasible for WebRTC. They are comparing the structural similarity between the produced and the received frames, but it's not simply not feasible and not adaptable, especially in real time. Other approaches like LEAPS and VMEF, which is considering the bitrate in their score calculation, are more practical, but they still need to be adapted on the stats which is available for WebRTC. A network part, as I said, the second component, plays a huge role in any score calculation. When congestion happens, all media are affected. So you need to come up with some kind of aggregation for the peer connection that compound the network reliability and the video content and the video and audio content score calculation. And here is the second problem comes when we are talking about score calculation, is the aggregation. Every aggregation is smoothing out information. And then we are talking about several levels. So even if you find something which is nicely calculating the score for a peer connection, I have a bad news for you because one client may have many peer connections, so you need to aggregate across those. And then everybody cares about that, what was the score, and then give me a score, give me one number. So you need to aggregate over a time series of data, which is an aggregation of an aggregation of an aggregation. And then the original question we finally came, how was the meeting in quality X, which is an aggregation of client. I think you see the problem. So, sum up, the question of how was the meeting in quality, and how was the quality in meeting X was turning out to be one of the most challenging. But it's also one of the most essential one, because when you are able to calculating somewhat an approximation of quality of experience with some kind of score mechanism, you can have some meaningful insights. And why it is very useful? Because of adaptive media systems. If you define controllers of your systems, which is affecting the quality of services, and you have valuable insights, when you're connecting those two, you are closing the loop and enabling active adoption. An essence of adaptive multimedia systems. And that is basically what we might want to head on. When WebRTC first emerged, the priority was to build a system which worked, rather than a system which is able to self-tuning or self-adaptation. The artificial intelligence was not yet widely available or easily integratable. And that has been changed over the last years. The AI component is easily integratable, WebRTC has stabilized, and more platforms are exploring the closed-loop self-adoption, where they are using artificial intelligence to balance between quality of service and quality of experience. When I was initially developed an open source, I didn't mention, but I founded in 2022 an open source project, WebRTC, which is maintaining and I'm developing tools for evaluating WebRTC calls from the WebRTC stats. And when I initially started developing it, I thought that it is providing a reliable score metric for quality of experience should be an out-of-the-box service for any WebRTC systems. I believe that providing an objective score is good because we can actually compare different systems with each other. I assume that the system context is not so relevant in order to provide such relevant score, such objective scores, and I underestimated the importance of expectations of usability. Users cannot care less about comparable scores. Managers are missing key KPIs in order to, if the scores are disconnected from the application context, and developers will not be able to pinpoint the root cause. So today I can say you in confidence that monitoring shouldn't be outsourced. It should be fully integrated in order for you to pinpoint, do key KPIs, finding the root cause, have better user experience, and basically close the loops so available to, enables you to make an adaptive multimedia system. And it's not working. Sorry. So let's break observability into two main parts, client side and server side. They both play critical roles, but their responsibilities and strengths are different. The client is the source of the truth. It is where the user interacts, raw stats are pulled, environment has been detected, client issues are happening. The server side is the view shifts. It is where all of the client's data are seen, that you can connect the dots. For example, if you have some kind of server observability, you can detect if one client is not receiving some media from another, and then you can notify the right side of the client, avoiding the ghost conversation that can you hear or see me, which is usually often happens. Another key role for a server is the saving data. When a user complains, you might want to pull out the stats, replay the calls, and then identifying when the quality degradation happened and what might cause the potential issues. As I said earlier, it should actually save in an application context in order to have better view what happened. So let's talk about building an integrated monitoring system for WebRTC in your WebRTC systems. The client is the source of the truth, but you also need to save data and correlates with the client-provided data. If you are looking at the full stack, the functionalities you need to cover when you are building a integrated monitoring system is to collect, transport, analyze, react, save, and scale. And the questions like how do we transport the stats, how do we analyze it, what kind of queries we are running, where do we save it, is that although there are not simple answers for these questions, what I have learned from experience, I will try to share it with you in a couple of minutes. One of the things is that, for example, let's start with collecting and saving. When WebRTC stats are pulled, they look like a batch of relational database rows. Because, for example, the outbound RTP streams contains the media stream ID, and media stream ID is referring to the media source stats. And the natural belief, or the common belief, is that it should be just saved in the corresponding relational tables. Although it sounds a bit nice, but often it's not the best choice. And why? Because you are not aggregating in columns, because you are hardly going to be query using the relational table advantages. So keeping it up, it comes with a cost, and you might want to avoid it because if it is not necessary. That brings us to the other question: is that analysis, because what you want to analyze with the data you are saved or your data you are on the fly analyzing with on the server side. There are two kinds of analysis really, which is you are doing. Either on-the-fly analysis, where you are able to detecting on-the-fly issues between the clients, or post-analysis. Most of the time, the analysis is basically generating a summary view when you are highlighting possible issues which happened with the client. And that brings to the scaling, because the intensity of the analysis is going to defining what kind of scalability you need for your service, which is detecting, monitoring your infrastructure. So for a long time, I believe that Observer service should be some kind of separated and with their own CI/CD pipeline. But nowadays, I am leaning forward to having a sidecar service next to the signaling or media server. If you are putting an observability service next to, for example, in the media server, you are immediately accessing to critical system context, which is otherwise should be collected some other way. But the downside is that because of the nature of the cascaded media, you will not access to all clients at the same time. If you are put it into as a sidecar to the signaling service, you might be accessing to all the clients at the same time, but there is little system context which you can grab from it. But what is the nice side when you are integrates in each of the service, into each of the service, you are reusing the CI/CD pipeline, and then it scales with the original, and the scales is ties back to the original servers. So it integrates naturally. Finally, let's talk about transport. Because the funny things with the transport, that you want to transport your stats to the server, is that when more and more participants are joining to the call and then more and more stats are available, it can go up to several kilobytes or even tens of kilobytes. And then transporting it actually frequently, you might causing incipient congestion, which is a bit ironic because you're setting up a monitoring system in order to improve the quality, but the monitoring transport will be the one which is degrading the quality. So this is why, although transports are essential in order to on-the-fly analysis, but it's very important to compress it as much as possible. When you are sending the raw JSON, it's not a good idea. Sending data JSON, which is the differences between consecutive polling, is a better idea. It's even better if you, for example, using some kind of predefined schema and then just use, for example, protobuf, and then sending the delta in each time. That's massively compressing the data you are sending. And building your own monitoring system. So I would like to recommend highlight some recommend some tools. There are many other there, but since I am the presenter, forgive me if I'm showcasing my own. So the client monitor GS from WebRTC is help you to polling and calculating. It's calculating many metrics for you. Also, it's having ready samples, a sample object which is ready to ship to the server. There are predefined schema. There are predefined schema which enables you for different language bindings, samples encoder and decoder for efficient transport on the server and the client side, and an observer GS which is enabling you on the server to analyze it, the clients on the fly, wherever you are putting your service. The descriptions are available in observrtc.org. And yeah, for today demos, I made something interesting, which is started last year here in RTC.ON. Hoppa. Aha. Okay, I think I ran out of time, sorry. Okay, just quickly. So last year with the L7MP guys, we had an interesting conversation when they introduced the Stunner as a native Kubernetes gateway for their turn. And I had this kind of conversation that, what if we do a native Kubernetes SFU, where there is only one IP and one port used, and then the full horizontal scalability of the SFU is behind the gateway. And we made a proof of concept, and I wasn't able to resist to integrate WebRTC to that project. It is called Cloud SFU. You can read about Cloud SFU, how we made the turn service and the Stunner gateway as the full gateway, and then exposing one IP, one port for the whole Kubernetes, and then making the SFU horizontally scalable. And I was made some demo for showing the monitoring capability and how you can use it. Wait a sec. If I can be able to. So, if you wondering how to monitor your WebRTC or what to do with, for example, what you can do with the client monitor, there is this nice thing, monitor cloud SFU.dev, and you can just working around and then see what kind of metrics are available if you are using or what to do, and how to, for example, attach system application context. So later you can able to use it for your own. Here is that the compression rate, I hope. Yeah, then for the samples, please explore. I don't want to waste so much time about it. Because of the Cloud SFU, that how to integrate the WebRTC. You can also explore that. Why is the context is very important and the integration is crucial? Is that because if you have really the context, you can really connect the dots. So, for example, it's not just the client that what kind of application and CPU is or device is used, but also it's like naturally you can navigate the router or the SFU, the regional SFU, the RTT, or everything what your system was used at the time of the call, which is really helping you to either pinpointing the issues or making key performance indicators and making basically the user experience better. And yeah, basically that was my presentation. To wrap it up, please remember, in order, if I can help you, please remember to add application context and save it with your stats, correlate it. That will massively help you to pinpointing any kind of issues. Please also make careful when you are making score mechanism calculation, but it's also an essential one. And I am encouraging you to integrating your monitoring system in order to take full control of your service. Thank you very much for your time, and yeah.
Thank you very much, Balazs. I think that we have time for one question, at least. Anyone? There's a gentleman over there.
What's the, like under the hood, the implementation of the attaching of the context? You're basically inserting it into the transport as a pack, like some like service packets, or doing some other mechanism?
No, you are using the client monitor JS as a library, so you are integrating into your application and then adding any kind of context you wish, injecting.
Okay, so it's like it's the task for the developer, right?
Yes, naturally, because you know the better your application. The monitor is collecting all of the stats, derived metrics which can be meaningful, but you can attach any kind of context or attachments to different objects for tracks, for applications, for peer connections, and it's naturally shipped with the samples.
Okay, cool.
All right, let's finish up with another round of applause for Balazs.